What if I told you the most powerful computer you own? The device you check before you even get out of bed was built by machines so precise, they can place a component smaller than a grain of sand 50 times per second. No factory workers holding tiny screwdrivers. No hands soldering wires. No one manually assembling the brain of your phone. Instead, it's a silent orchestra of robots, lasers, conveyor belts, and artificial intelligence working in perfect synchronization. Today, we're stepping inside the automated assembly lines where smartphones are born. Before a single part touches a conveyor belt, the journey begins with digital design. Engineers create microscopic circuit layouts using advanced computer-aided design software. Every connection, every chip, every antenna line is mapped with extreme precision. The tolerances are measured in fractions of a millimeter. There is no room for guesswork. Once the blueprint is finalized, production begins. Inside the factory, reels of electronic components arrive in sealed packaging. These aren't large pieces you can easily see. Many are smaller than a fingernail. Some are nearly invisible to the naked eye. Resistors, capacitors, processors, memory chips, thousands of tiny parts waiting to be assembled. The first physical stage is the circuit board preparation. Blank green boards called printed circuit boards or PCBs travel down a conveyor belt. They look lifeless, just fiberglass and copper traces, but within minutes they will become the brain of a smartphone. The board enters the solder paste printing machine. A stainless steel stencil aligns perfectly over the board, and microscopic dots of solder paste are applied exactly where components will sit. Too much paste can cause short circuits. Too little can cause weak connections. The machine deposits it with surgical accuracy. Next comes one of the most fascinating machines in the entire factory, the pick-and-place system. High-speed robotic heads move with astonishing speed. Tiny vacuum nozzles pick up components from reels and place them onto the solder-pasted board. Cameras inspect each component before placement. If it's rotated slightly wrong, cracked, or misaligned, it's rejected instantly. These machines can place tens of thousands of components per hour, faster than the human eye can track. It's not just speed, it's precision. Placement accuracy is often within 0.01 millimeters. Within seconds, the once empty board is covered in miniature electronic parts. But they're not attached yet. The board now enters the reflow oven. This is a long tunnel divided into temperature-controlled zones. As the board moves through, heat gradually increases until the solder paste melts. The liquid solder bonds each component permanently to the board. Then it cools down in a controlled manner to form strong electrical connections. The temperature profile must be exact. Too hot and components can be damaged. Too cool and solder joints may be weak. The process is carefully programmed and monitored. After soldering, the board undergoes automated optical inspection. High-resolution cameras scan every single component and solder joint. Artificial intelligence compares the image to a perfect digital reference model. Missing parts, poor soldering, slight misalignment, anything unusual triggers an alert. Defective boards are automatically removed from the line. There's no debate, no compromise. Some boards go through additional X-ray inspection. This allows the system to see hidden solder joints under large chips where cameras can't reach. Even invisible flaws are detected. Once the board passes inspection, it moves to advanced assembly stages. Now comes the installation of the main processor and memory modules, the brain and memory of the smartphone. These components are often mounted using highly precise robotic arms in controlled environments. Dust and static electricity are enemies here. Factories maintain strict cleanliness and anti-static controls to protect sensitive chips. After placement, additional soldering processes secure these high-value components. The board is tested electrically to ensure signals flow correctly between circuits. At this point, the motherboard is alive in potential, but it still needs a body. In parallel production lines, smartphone displays are being assembled. Layers of glass, touch sensors, and display panels are bonded together using optical adhesives. Robotic systems apply even pressure to eliminate air bubbles. Vacuum chambers remove trapped air, ensuring clarity and durability. The display must be perfectly aligned within the phone's frame. Even the smallest shift can cause cosmetic defects or touch sensitivity issues. Automated alignment systems ensure pixel-perfect positioning. Now comes battery installation. Lithium-ion batteries are carefully handled by robotic arms. Adhesive strips are applied automatically to secure them in place. Immediately after installation, voltage and safety checks are performed. If readings fall outside strict parameters, the unit is flagged and removed. Battery safety is critical. Automated systems monitor every stage to prevent defects. Next, the motherboard is placed into the phone's chassis. Camera modules built with microscopic lenses and image sensors are inserted by machines capable of positioning them precisely. Even tiny shifts can affect image focus. Speakers, microphones, vibration motors, antennas. Each component is inserted in a defined sequence. Robotic screwdrivers tighten screws to exact torque specifications. Not too tight, not too loose. Each screw is logged by the system. If torque values fall outside acceptable ranges, the unit is rejected. As hardware assembly completes, the smartphone looks finished from the outside, but it's still empty inside. The phone moves to a software flashing station. Robotic connectors plug into ports. The operating system is installed automatically. Firmware is programmed. Security keys are embedded. Then comes the first boot. The screen lights up for the first time. Automated diagnostic systems test everything: touch sensitivity, camera alignment, microphone clarity, Wi-Fi signal strength, Bluetooth connectivity, sensors, buttons, display brightness, battery charging. Each test runs in seconds. Thousands of phones are tested every hour. If anything fails, the phone is removed for repair or recycling. Some units undergo stress testing. Robotic systems press buttons thousands of times. Charging ports are plugged and unplugged repeatedly. Drop tests simulate falls. Environmental chambers expose phones to extreme temperatures and humidity. This ensures durability before the phone ever reaches a customer. Finally, the device enters the packaging line. Air jets remove dust particles. Protective films are applied automatically. Boxes are assembled by folding machines. Accessories are inserted with mechanical precision. Barcodes are printed and scanned, linking each phone to a serial number for traceability. The box is sealed. Within hours of starting as a blank circuit board, the smartphone is now a fully functional device, ready for shipment across the world. What's remarkable is how little human intervention occurs in the core assembly. Humans supervise, maintain machines, monitor systems, and manage quality control. But the delicate, repetitive, high-precision tasks are handled by automation. Why? Because automation delivers consistency. A human might place a component accurately dozens of times. A machine can do it millions of times without fatigue. Automation also makes scale possible. Global smartphone demand reaches billions of units. Without automated assembly lines, production would be slower, more expensive, and less reliable. Each smartphone represents thousands of precisely timed operations. From solder paste printing to pick-and-place placement, from reflow soldering to optical inspection, from display bonding to software installation, every step is choreographed. It's a symphony of machines working in harmony. The next time you unlock your phone, consider this. Inside that slim metal and glass body lies a motherboard assembled with microscopic accuracy, a processor positioned by robotic arms, solder joints formed inside temperature-controlled ovens, components inspected by artificial intelligence. Your smartphone is not just a product. It's the result of one of the most advanced automated manufacturing systems ever created, all built on assembly lines that never sleep. And somewhere right now, in a brightly lit factory across the world, conveyor belts are moving, robotic heads are placing components, ovens are heating, cameras are scanning, building the next device that will soon land in someone's hand. Maybe even yours.